Yeah. Give me a second. Sarah, how do we get x cube plus 1 upon x cube from x plus 1 upon x?
For
We cube it? Cube
cannot hear you, sir.
it? Will we cube this
One
from x plus 1 upon x? We want x cube plus 1 upon x cube. So should we cube it?
yes, it will be
Expand?
x.
Yeah.
It will be x plus one of x plus 1 upon x cube. The whole thing raised to 3 minus of 3
No.
multiplied by
Yeah.
3 multiplied by x plus 1 upon x.
Right. So x cube plus
1
1 upon x cube is nothing but x plus 1 upon x the whole thing cube minus of 3 into x plus 1 upon x, right? So what is that equivalent to? But do we need to do this? Because we have a 2 cubed also. So why can't you just expand x plus 1 upon x the whole thing cubed instead of doing this? So what is x cube plus 1 upon x cubed over here? Expand this.
x cube
Yeah.
plus 1 upon x cube
Yeah.
minus 3 multiplied by
No,
x plus 1 upon x.
Plus. This is where you all go wrong. See, this is one common mistake. Everyone pay attention what you all do here. When we have x plus 1 upon x, the whole thing cube, this is x cube plus 1 upon x cube plus 3 into x plus 1 upon x. Please remember this. Okay?
Okay.
Now, when we want only x cube plus 1 upon x cube, how would we get that? Only if we transpose this to the other sides. So there I would get x plus 1 upon x, the whole thing cube, minus of 3 into x.
Minus of, okay, sir.
So whenever we have only the expansion of the entire identity, all are plus. Similarly, if I have x minus 1 upon x, the whole thing cubed, I'll get x cube minus 1 upon x cube. Then what will I get, plus or minus?
X, we'll get plus.
Minus. Minus 3 into x minus 1 upon x. All are minus.
Oh, okay, sir.
Okay. But if I get only this value, then when I transpose this here, what will happen? It changes to plus. Is this clear? So remember, expansion of x plus 1 upon x, the whole thing cube, everything is plus. Expansion of x minus 1 upon x, the whole thing cube, everything is minus. This is a very common mistake you all do. Therefore, pay attention over here. Unnecessarily, you will lose marks. Okay. So this is clear, which is equivalent
Yes,
to 2 cubed is 8. Right? Okay, solve further. What is
So
x plus 1 upon x?
x cube plus 1 upon x cube
X plus 1
plus,
upon x is 2, right? So it'll be 3
yes,
into 2 is equal to 8.
3 into 2 it will be 8.
So what is x cube plus 1 upon x cube?
So x cube
8
plus 1
minus
upon
6.
x cube will be 2.
Okay. Now we want x4 plus 1 upon x4. How would we get that?
On expanding that, we will get x raised to 2 plus x raised to 2 the whole thing square minus 2. Oh,
We just found out x squared plus 1 upon x squared.
oh yes.
So if I square that, I will get x4 plus 1 upon x4. Yeah? Expand.
Yes. So, x square plus 1 upon x square and x raised to 4 plus 1 upon x square
X squared is x4
plus to 4.
Why 4?
3, 2, 2.
2 into AB, 2 itself is equal to
Yes.
4.
4, yes.
X4 plus 1 upon X4 is also equal to 2, 3.
2.
So
Okay.
putting 1, 2 and 3 together, we see x squared plus 1 upon x squared is equal to x cubed plus 1 upon x cubed, which is equal to x4 plus 1 upon x4.
Okay.
You're getting confused, Sarah, in the identities. Okay, Sarah, if you get confused, okay, take our base. We have a plus, okay, all of you pay attention here. What is a plus b the whole thing squared, Samita? Yep. Samita, your voice is again coming like Donald Duck. It's not yet. Is her voice clear to everybody? It's only issue with me. No?
No, sir, even we can't hear you.
Okay. Sarah, what
More
is
like a
the whole thing
chipmunk.
squared? No, Samita, I think there's some issue with your mic. Sarah, what's a plus b the whole thing squared quickly?
Yes, sir. It will be a square plus 2ab plus b square.
Right? So what are we doing? We are squaring this, we are squaring this, and we're doing 2 times the product of these two, right? Because it is 2, so we're doing 2 times. Is this clear?
Yes, sir.
Let's do this with a cube. We have a plus b, the whole thing cube. So again, what will we do? First cube this into
A
plus
cube.
3 times, because this is 3, so 3 times the product of these two. So what will we get?
Oh,
We'll get a cube plus
a cube plus of b cube
plus 3
plus
times the product of these two, which
3a.
is b, and we'll add a plus b. So there is a lot of common relationship between a square plus 2ab plus b square and a cube plus b cube plus 3ab into a plus b. Did you, till here it is almost the same, right? Did you understand this? Plus minus.
Can you hear me now?
Yeah, I can hear you clearly now. Okay. Now look at a plus 1 upon a the whole thing cube. Same way. Cube, 3 times product plus into another one. Sarah, tell me.
It will be a plus 1 upon a cube plus 1 upon a cube plus 3 multiplied by a plus 1 upon a.
No. 3, right? Now this a and a gets cancelled, so we can just remember that whenever I have 1 upon this part gets cancelled. Otherwise, it's the same thing as this. Okay. Now, a lot of you get confused between a plus 1 upon a. The whole thing cubed is a cubed plus 1 upon a cubed plus 3 into a plus 1 upon a, and a cube plus 1 upon a cube is equal to a plus 1 upon a cube minus of 3 into a plus 1 upon a, right? There's a lot of confusion between these two. If you want to avoid the confusion, start from this equation only, this identity, and derive this one. It will only take you one more step, but you will never go wrong. Don't directly go to this one until you're confident. Ananya, Sarah, are you clear on this?
Yes, sir.
You can always start with a plus 1 upon a, the whole thing cubed, and then reach directly this by transposing this here. In that way, what will happen? You will avoid making mistakes of plus minus. Similarly, if we have a minus here, remember, everything is minus. So if you have a minus, what will this become, Ananya?
A minus 1 upon a cube.
Is?
Sorry, I was telling the other side. A minus, yes, plus 3.
No, this is where you're going wrong. Minus 3 into a minus 1 upon a.
Okay.
Okay, everything is minus. Now, when you need a cube plus 1 upon minus 1 upon a cube, you transpose it to the other side, so it becomes plus. Okay, so start with only these two, and then derive a cube minus 1 upon a cube and a cube plus 1 upon a cube. Is everyone clear on this until you gain confidence here? If you mug this up and you remember it properly, do this. Otherwise, always start from this equation itself, this identity. Clear, everyone? Okay, which was the other sum? We're through with 11th, I think 15 and 16. 15th, who had asked me? Ananya or
No, sir, Sarah.
Sarah? Sarah, unmute yourself.
Yes, sir.
Tell me, if the two positive numbers x and y are such that x is greater than y, and the difference of these two numbers is 5. So what will we do? X minus 5, y is equal to 5, or will I do y minus x is equal to 5? If x is
X minus y will be 5,
okay, and the product is 24,
and so x and y is equal to 24.
right? So we need to find
Yes.
the sum of these numbers. So what are the sum of the numbers means?
Sum of the numbers x plus y.
Right? We need to find this. Tell me, what do we do?
You can use the right.
Hmm?
Here we can use x plus y the whole thing square multiplied by x minus y the whole thing square.
Do we have an identity for this, which related x plus y and x minus y?
Yes.
What was it?
X plus y multiplied by x minus x plus y the whole thing square multiplied by x minus y.
No, Sarah, you need to learn the 16 identities I gave you. X plus y, the whole thing squared. Ishan, can you tell me the identity?
It would be x plus y whole square minus x minus y whole square is equal to 4xy.
Sarah, did you forgot? There was an identity which related x plus y and x minus y. You need to remember this. Can you do this now?
Yes.
Sir, I've done it with a different method.
Tell me.
Okay, I've done the same thing almost, but x minus y the whole square is equal to x square plus y square minus 2ab.
X
And
y plus y squared minus 2xy, then ab kahan se aa gaya?
oh, sorry, xy. Yeah.
Yeah, then
So 25 is equal to x square plus y square minus 48.
yeah, that's fine also. So you can get x plus y.
Yeah.
No, but you will get x squared plus y squared. Then what will you do after that? Okay, so you do x squared plus y squared minus of
Trans
48.
yeah.
Then
X square plus y square is equal to 48 minus 25 plus 25,
which is
73.
73.
3.
Then
X plus y whole square is equal to x square plus y square plus 2xy.
x. So why do you want to do such a long way for a 1 mark question? You getting it? I am fine with it.
Yeah.
You're going to do this, then you're going to do x squared plus y squared plus 2xy again, and then you're going to replace this here, and then you're going to do this again. But this
Yeah.
will take you time to solve, right? If you see this as
Yes.
only one step involved, 2 steps here,
Yeah.
because this is a 1 mark question, we have maximum 2 minutes to solve this, including reading the question and writing it the answer down. So try to minimize wherever possible, use the direct identities we know.
Okay.
This is absolutely correct. There's no problem doing this, but it just waste your time. Yes, Prashant?
Sir, with this x square plus y square is equal to 23, we can use x plus multiplied by x minus y gives x square plus y square.
X plus y?
Multiplied by x minus y gives x square minus
X plus y into x minus y is 1.
x square minus y.
And we have a plus here.
Yeah.
So wrong, right? We can't use this. This is the only way we can do it, but this is a longer method. That's all. So if we use direct identity, we save time. So use this identity directly and solve it. Sarah, I hope you'll be able to solve it further.
Yes, sir, I will be.
And second one is difference of the cubes. That's x cube minus y cube. Will you be able to do this also? Same thing. When x minus y is equal to 5, cube this and solve. Right? And the third one is sum of the cubes. That's x cube plus y cube. Same way. When we have x plus y, from here we got x plus y, which was I think 11. And cubing both sides. Come on. There's a power failure again and again. I don't know what the issue is. I'm connected on mobile data now. It should not give an issue. Give me a minute. Sarah, are you there?
Yes, sir.
You know how I can get x cube plus y cube?
Yes.
Yeah?
Yes.
15 question who had asked?
But should it be 5 cube instead of 11 cube?
X plus y, I think the answer should be 11.
Okay. Let's see.
Check your answer. See if you're working, you should get 11 there. Okay. Who had asked for the 16 question?
Or I had
Okay, Ananya, let's do that.
4x square plus y square is equal to 9. Sorry, A. Find and xy is equal to b. Find 2x plus y.
Okay. So again, what is the relationship between these two? This is basically the square of this,
Yes.
right? Let's try to square this. What will we get if we square this?
2x square 4x square
Yeah,
plus y square plus 2 multiplied by 2x plus y.
how
Yeah.
plus y?
Sorry, multiplied.
So 2 into 4, so we'll get 4x.
Yes.
Okay.
And
What is 4x squared plus y squared?
4 a plus 4xy.
xy is b, so we get 4. So 2x plus y, the whole thing squared is nothing but a plus 4b, right?
Okay.
And we want the value of 2x plus y.
Plus y.
So we take the square root here and here. Therefore, 2x plus y will become plus minus root of a plus 4b.
Okay.
Yeah, Ishan?
Like 4 is a perfect square,
Yeah.
so we can do a plus, root a plus 2 root b.
Which part? Here about here.
Yeah.
But this is a plus 2b. Problem is it's not into.
It would be
If I have 3 plus 9, root of 3 plus 9. Can I do this as root 3 and I take out 3 outside? Because root 9 is 3, so can I take out 3 outside? Ishan? Got it? So, because this is nothing but root 12. Therefore, also we cannot combine root a and 4b together. Yes, what we could have done is, you can write this as root a plus root of 4b. That would be root a plus 2 root b. This is also fine. Both plus minus. Okay. Otherwise, just leave it here. This is also fine. Absolutely. There's no problem there. Ishan, I hope this is clear in the difference between having a plus 2b and a into 4b.
yes.
Right? So you can even, if you got this answer as root a plus 2 root b, then that is also clear. That's not a problem. Fine, any other doubts? Any doubts, anyone?
No, sir.
All clear with 4B? Okay. We have briefly covered expansions. Let's go ahead then. Earlier we had covered expansions regarding the type of x plus e into x plus b. Right? Paki, can you tell me this expansion? How would we do this?
Yes, sir. We'll do x square
Yeah,
plus x into a plus b plus ab.
that's the combined one. That multiplied individually first.
Oh, x square plus x. Just a second. Okay,
Ax,
xb
right?
x.
First term into first, second into second, combine the inners, combine the outers. Remember?
Yeah.
So we get x
Yeah.
square plus xb plus ax plus ab.
Let's see. Yeah.
Now, if you look over your x is common, so we can take it as x outside a plus b plus ab,
Plus
right?
ab. Yeah.
All of you are clear on this? Now, what if we have a plus minus here? Now, let's make this a minus. So we have x plus a into x minus of b. What we will end up is x square plus again x into, or you can say a minus b into x minus of ab. Right? Now, if I have x minus a into x plus b, we'll end up with x squared minus of a minus b into x minus ab. And lastly, if we have a minus on both the sides, x minus a into x minus b, we'll end up with x squared minus of a plus b into x plus ab. Okay. What I usually do is I don't mark these four formulas up, identities. I solve it individually. So if I have to solve this, for example, you know what I'll do? I'll quickly solve this. It'll take me maximum of 10 seconds. I'll do x squared minus x squared minus of ab minus of ax plus bx, right? And I'll take out these two common here. So if I take this as common, I'll change the sign here. So I'll get x squared minus ab minus of x into a minus b, which is the same as what we got over here. Okay. So in case you get confused, you can always just multiply, get the full terms and then combine the x ones. So in this way, you will not make an error of the signs. Is this clear, everyone?
Sir,
Yes, Sarah?
sir, can we multiply just like x multiplied by x and then x multiplied by b, then a multiplied by x and a multiplied by b?
You
That
would do either you would do x plus b minus of a into x plus b.
yes.
But why do you want to do this? This was last year, right?
Yes.
Do it this year. First term into first term. Okay. Second term into the second term. Combine the inners. Combine the outers.
Okay.
So what is first term into first? Let's do this one. Sarah, tell me this one. Okay. Do it quickly. Mug it up like this. So x minus a into x minus b. So first term into first term, what will we get?
X square
Second term into second term. Minus a minus b.
ab plus ab
Combine the inners.
minus ax and then minus xb.
Minus bx, right? Now these x terms we can combine. So as soon as I take a bracket here, I need to change the sign. Remember this, this is important. Change the sign. So what will I get? X squared plus ab
X square plus
minus
ab
of x.
minus x plus ab. Yes.
Right, that's what we got here. So you see, you can quickly reach to this identity if you have a problem remembering the plus and the minus.
Oh, okay.
Got it? So it's again first term into first term, second term into second term, combine the inners, combine the outers. That's the universal way in which you can easily remember to multiply a binomial with a binomial. Okay? Quickly do this question now. X plus 3 into x minus 5. Quickly. X plus 3 into x minus 5. Either use the identity directly or solve it step by step. They won't cut your marks. Isha, that is correct. Rest of your area. Saramya, that's wrong. No, Saramya, that's correct. Ananya, that's correct. Saramya, remember the x terms have to come first, then the constants will come. Sarah, that's correct. Paki, again, the x terms will come first, then the constants, so it's correct. Rearrange the terms. Very simple. So if we use the identity directly, we'll get x squared plus 3 minus 5 into x plus AB, which is 3 into minus 5. So what will we get? X squared minus 2x minus 15. Right? This is if we use the identity directly, because we know that x plus a into x minus b is equal to x squared plus a minus b into x minus ab. So here you just need to take care of the signs. If you remember them, that's no problem there. Okay, let's do one more. X minus 3, x minus 5. Ananya, no, that's incorrect. X minus Sarah, that is correct. Paki, that is correct. Ishan, that is correct. Saramya, that's correct. Samita, that's correct. Ananya, check your working. Ananya, unmute yourself.
Yes, sir.
What's x minus a into x minus b?
X square
Yeah.
minus 5.
Oh no, x minus a into x minus b. I'm asking you the identity.
Yeah.
X squared minus
Oh.
of plus b into x plus ab.
Yeah.
So now I
Yes.
replace it with this 3 and 5. Minus 3 and 5. So what will we get?
X square
Minus of
minus 3 plus 5 x plus minus 3 into 5,
which is
which will be x square minus 2. Okay, yes.
what is 3 plus 5?
Plus,
8.
yes.
Why
Sir,
did
I
you,
just
how did you get 2 or how did you get 7? Plus 15.
sir, addition mistake.
Aryan, plus minus sign, how did you make it?
Yes, sir, it happened by mistake. I was writing x square minus 8x.
Yeah, now?
Yes, sir.
Okay. Is there a easy way to remember this? Just give me a second. Minus 8. Okay, let's do this one. See this one. I'll just take one more minute. X plus a into x plus b. This is x squared plus a plus b into x plus ab. This is clear, everyone? Yeah? Paki, have a doubt?
Sir, I was asking that it is absolutely okay if we don't use the identity, or like it is compulsory to use it in the
If they
exams.
mention use identities, then you will have to use identities.
Okay.
If you don't, then you can do it the long way also. Okay, but I'm telling you easy way. Just figure out. I just noticed something. It may work out. Let's start. Let's see if this works out. If this one is clear, everyone. Now look at x plus a into x minus b. Okay, so this is x squared. This is fine. Now the problem is plus or minus. What do we need, right? What is over here? Plus. So we'll have to put a plus here. Okay. So we get, if you see from here, we get plus a and we have minus b, and we're basically putting a bracket here. So what will we get? We'll get plus a minus b into x, right? And for the last term, we're getting plus a into minus b. What sign will come? Minus ab? Yes or no? Getting it? Again, let's look at another one. X minus a into x plus b. The first is x squared, no issue there. Now what do we have? We have minus a plus b. Paki, pay attention. We have minus a plus b, right? But as soon as I put a bracket here, what happens to the sign inside? It changes. So what do we get here? We get minus, because this is outside, minus a minus b into x. And what is minus a into plus b again? Minus a, right? And lastly, x minus a into x minus b, again x squared, then I get minus a minus b. So if I put a bracket here, what will happen? I'll get a plus. So I'll get minus a, sorry, minus of a plus b into x, and I have minus a into minus b, which is plus ab. Did you see this? So even using the identities, you can directly derive the identities from the multiplication itself, the binomial itself. So like again, let me take another example in the same one. Like we do x minus 3 into x plus 5. So first is x squared. Then this sign here. What sign do we have here? Samita, what sign?
Minus.
So what do we do here? Minus. brackets minus of 3. So we have minus 3 plus 5. When I put a bracket here, what does this become into a minus? So I'll get minus 3 plus minus of, I'll get 3 minus of 5, isn't it? Into x. And in the end, I'll get minus 3 plus 5, which is minus 15. So this becomes x squared. Because this becomes minus 2, I'll get plus 2x plus 15. Sorry, minus 15. Right? So you see that even from directly, if you have these two steps, you can still derive the identity very easily. Please copy this down if you want how to get the identity. In case they ask you the identity and you don't remember the plus minus, you can always solve it this way. Ishan, is this clear?
Yes, sir.
Paki, Ananya, Aryan, Kamita, Sara, all clear?
Yes, sir.
Okay, so this is another way in which you can, try to derive the identity if you forget the plus minuses. Easiest obviously is to learn them, but yes, I understand after 6 months you won't remember. So you can derive it directly. Okay, so that's it for today. I'll connect with you again tomorrow. You can log in for science. Bye everyone.
Thank you.